Okay, we're getting into some basic homework problems. I'm going to use over here something called a sample space that we'll look at in future lectures and homeworks, but I'm only going to use the top rows red for this first problem. The red values in the top row. This is a reference to 2 dice being rolled at one time, but I'm going to imagine that I'm only rolling a single red die. So I got a red 1, 2, 3, 4, 5, and 6. That represents what I have. What's the probability of rolling a 6? Well, out of 6 dice, how many of them are 3s? Let's look across the reds. 1, 2, 3, 4, 5, 6 reds. How many of the red ones are 3s? Just that one. 1 6, and it does not reduce, so that's finished. Now we want to see if we get an odd number. We have 6. We're going to continue to have 6 on the bottom. But how many of the red numbers across this row are odd? There's 1, nope. There's a second one, nope. There's a third one, nope. 3 out of 6. That is the 1, 3, and the 5 are odd. That does reduce to 1/2, but I will accept 3, 6, and so back. A number less than 3. We have 6 possible numbers. How many of them are less than 3? The 1 is less than 3, the 2 is less than 3. 3 is a tie with 3, it is not less than 3, nor is 4, 5, or 6 less than 3. We have 2 of the 6 numbers are less than 3. Acceptable is 2 over 6, or 1/3. If you give me 1/3, that's a reduced fraction, lets you know the reduced version, but really 2 of the 6 shows full understanding of the probability. 2 of them successfully were lower than 3 out of 6 total dice that were available. A number greater than 9, the probability here, when we have 6 on the bottom, how many of them are lower than 9, are greater than 9? Not the 1, nor the 2, nor the 3, nor the 4, nor the 5, nor the 6. I prefer to ask the question this way, where you get 0 out of 6, which is fine, or you can get 0. What's the probability that your number, when you roll a single die, will come up greater than 9? It's impossible, and the probability of a number that's impossible will be 0. A number greater than 4 or even. Let me start here, knowing that the probability is going to be based out of 6, by writing the numbers that are greater than 4 among the red numbers. 1, 2, 3, 4, 5, 6. Greater than 4 are 5 and 6. Those are possible as we get going. Those are greater than 4. So they survived being greater than 4. But then, because I had these, and then you're not greater than 6. And you guys are still alive. And then we come back the other time. Which ones of you are even? Right? So you're not even, but you're already gone. You're not even. And then 6 is the only one. Single value that is even. Oh, or, my badness, strike that from the record. You heard me saying and. That's the mistake that people can make, as you saw me making here also. Let's go with it again. 1, 2, 3, 4, 5, or 6. Let me get every number that is greater than 4. There's the 5 and there's the 6. So those are already in, no matter what happens the rest of the way, thanks to this being an or. And I want to know, what about numbers that are even? 2 is even, 3 is not even, 4 is even, 6 is even. 6 got circled twice, but how many numbers are encircled at all? 1, 2, 3, 4 out of 6. That's acceptable. Could also be 2/3. But with the or, we needed at least one feature to be true. It was okay if it had both features true. Now, numbers that are less than 5 and odd, let's set them up again. 1, 2, 3, 4, 5, and 6. I want numbers that are less than 5. So 1 is good, 2 is good, 3 is good, and 4 is good. 5 is out, 6 is out. So they're already dead. They cannot be part of my values that are acceptable. And they have to be odd. 1 is odd and survives. 2 gets taken out, not odd. 3 is odd and survives. 4 gets taken out for being even, not odd. 5 is odd, so 5 doesn't need to be re-scratched, but 5 is already gone. And 6 offended on both counts. 6 is not odd, 6 is not less than 5, but it doesn't get double slammed. There's no double jeopardy here. We wound up here with the 1 and the 3 that are less than 5 and at the same time are odd numbers. So in this case, the probability is 2 out of 6, which reduces to 1/3. But 2 over 6 is good for me. I really understand that you know what's going on. The class is made up of 7 English majors, 2 math majors, and 6 art majors. 7 plus 2 plus 6, 15. There's the bottom of my fraction. Probably that someone is an English major randomly. Of the 15, 7 are English majors. math major, the probability is, of the 15 people, only 2 are math majors. An English major or an art major. So, we can be an English major and get in that way, or an art major and get in that way. This gives us 7 plus 6 of the 15. 13 out of 15. Does not reduce, so that's what the answer would have to be. Not an art major. Everyone but the art majors. So what that is take everyone, one as a probability, and subtract off there the art majors, which is 6 of 15. Okay, 1 minus 6 over 15 will get you 9 over 15. You can make it 15 over 15. Subtract to 9 over 15. That's fine. Dividing by 3's will get you 3 over 5. But in actuality, the 15 minus 6 leaves you 9. So you got 9 that fit by not being art majors out of 15, and that would be 9 over 15. Not a math major would be something similar. We take our our full 1 over 1, right? And here we only have 2 out of the 15 that are math majors. That's 15 over 15 minus 2 over 15. Keep from the 15 on the bottom. 13 out of the 15 people are not math majors. What are your odds of winning a raffle with 1 winner out of 85 tickets if you bought 7 tickets? We'll look at both probability. I'm sorry, I said odds. That was just miswritten. I'm going to fix that. We aren't doing odds yet in homework 1. That is, what is the probability? Odds and probability, if you've already looked at odds or know a bit about them, they kind of do the same job, but they do it in a different way. For homework 1, what is the probability? Since I set odds up there, when I wrote it, I'll do that as well, but really we want to answer the question, what is the probability of winning a raffle ticket? You bought 7 tickets. There are 85 tickets sold. That's going to be our probabilities denominator. It's going to have 85 tickets that might win. How many of them are yours and will cause you to win? 7. And I guarantee, even if you win, you have 6 losing tickets. You might have 7 losing tickets and not win at all, but there's your probability. What about odds? Against you winning? You don't need to know it as we're only learning homework 1, but when you come back and review this later or after we learn odds, you can actually see that when there are 85 total, and 7 of them are wins, all the rest are losses. And the odds against you winning, when it says odd against, that means give me the number that's bad first. 78 to 7. There's 78 ways you can lose and only 7 ways you can win. That's called 78 to 7 would be the odds against you winning.